And then do I do the Toastmaster intro?
Yes.
Okay. So are you ready?
Mm-hmm.
Okay. So first we're gonna do Chassidy's presentation from last week.
Yes. All right. Hi guys, my name is Chassidy, and I am the group lead for experiment, for the radiant cycle experiment, for group 2. Actually, I have to do that one. Okay. So a little bit about the agenda. So first I'm going to go over the thermo background, and then we're going to talk about ideal versus real cycles, and then we're going to talk about the experiment process, then calculations, and questions after that. So to give a little background, the objective of this experiment is to understand the operation of a Rankine cycle, and then during that we're going to be recording the relevant data, and then also calculating the efficiencies and temperatures associated with the performance of a Rankine cycle. So a Rankine cycle has 4 basic steps. So first is the pump, and then to the boiler, then the turbine, and then the condenser. So to give like more specific background, the first stage is from the pump to the boiler. So basically the pump pressurizes the liquid water to send to the boiler, and then that's the calculation that's specific to the pump, to the work of the pump. And then the boiler turns the liquid into a superheated superheated steam, which is basically just high pressure steam, and that is the associated equation for that. Then for turbines, the turbine basically takes the high pressure and high temperature steam and turns it into energy. And then the condenser takes that steam from out of the turbine and turns it back into liquid water. So an ideal process basically represents perfect conditions within a Rankine cycle. So there are no energy losses. Pump and turbines are perfectly isentropic, and then it doesn't account for any inefficiencies, while a real process does account for those inefficiencies. So there's pressure losses, friction, and heat losses, and then there's also less work done within the turbine phase. So as far as the components within the lab process, there is the condenser tower, which takes the steam and it turns it back into condensate. And then it goes to the boiler, which inputs the condensate and then outputs steam. And then the generator uses the steam to produce power. And then the Rankine cycler program is what displays the data for everything within the equipment. So before we start, we have to make sure the area is clean, and then also make sure all of the equipment settings are in the off position. And then we do have to start preheating the process. So we have to make sure the fuel leak is checked. We do have to turn on the operation panel, as well as the master key switch, burner, switch, and combustion blower. We do have to check the purge lines as needed. And then the burner must be lit within 45 seconds of the switch being turned on. And the boiler pressure must be at a positive value within 3 minutes of the burner being turned on. So we do have to make sure that the boiler pressure rises to at least 110 psi. And the steam valve will be opened by turning it counterclockwise. And then there's a few other procedures that we have to follow. So we have to turn on the load switch and adjust it to less than 10 volts. And then also monitor the boiler pressure to make sure it decreases to about 40 psi. And then once we reach that, we can now close the steam emission valve and again raise it to 110 psi to prevent any pressure changes. And then from there, we turn on the load switch and then adjust it to maintain a current of about 0.6 amps. And then once the process reaches a steady state, then we will record the data and run the experiment. Run the experiment before recording the data though, because we did have problems with that last project. Then we have to measure the condensate and the boiler water that was consumed throughout the experiment and launch the software so we could start logging our data. After everything is logged, we shut down the station, clean up everything, make sure everything's back where it was before, and then we will analyze and plot the necessary data. So these are the calculations that I used to determine the efficiency of the Rankine cycle. So I used thermal, turbine, pump, boiler, and condenser equations, and basically turned it into one big equation for the efficiency. So for our predicted results, I used the pressure from the boiler and the pressure from the condenser to get an efficiency of about 16%. I also talked to another lab and they got an efficiency of about 0.71. My calculations may be a little off because I used different values from them, but these are my specific hand calculations for that. And hopefully we are able to get more specific calculations after the experiment is done. Any questions? Thank you.